Hello, my name is Celeste Strohecker, and this is my presentation on the Pythagorean Theorem. Let's start off with an illustration. I like this illustration because the boxes help you visualize exactly how the Pythagorean Theorem works. You see how A plus B equals C. The two shorter sides squared added together equals the square of the longer side. And here's the equation form. Here we assign values to the sides. The easiest one to use and the most commonly used is giving A value of 3, B the value of 4, and C the value of 5. These are all perfect squares, so they're easy to see how 3 squared is 9, 4 squared is 16, and 5 squared is 25. And if you were to want to check this, you could take 16 away from 25, and you would still have, it would give you 9 equals 9. So no matter how you do this, it's true. History of the Pythagorean Theorem. Right triangles have been used much in mathematics and even in ancient cultures. They saw that right triangles had special values. As long as 4,000 years ago, the Chinese and the Babylonians recognized this. Pythagoras was a Greek scholar who lived about 500 BC. He's the one that discovered this. He's credited with its discovery, at least. He proved that this works for any right triangle. Now we write it A plus B equals C squared, but that's not how Pythagoras would have written it. The way we do things with letters used to replace variables was actually introduced in the 16th century by Vieta, another mathematician. Pythagoras would have just written it out in words. An interesting fact is that we can't even prove that Pythagoras lived because nothing was ever found written by him. But still, he is credited, and we have evidence of his life based on his work. Euclid was a well-known Greek mathematician. He wrote the book called Elements, and in there he has proofs for the Pythagorean theorem. There's actually about 600 different proofs that are now available for the Pythagorean theorem. And even today, the Pythagorean theorem is very important in mathematics. I remember the first time I studied it, I was probably in about 6th or 7th grade. It's the basis of trigonometry, geometry, and algebra, and it's a very easy concept to grasp, and it's really interesting how no matter what the measurements for a right triangle are, if it's a perfect right triangle, this equation will always work.